Here's problem 4126. The graph below represents a wave function psi of x for a particle confined to -2 is less than or equal to x is less than or equal to 2. The value of the normalization constant a may be, well, we can see that psi of x is equal to a negative a in the range of -2 is less than or equal to x is less than or equal to 2, and our wave function psi of x is equal to 0 elsewhere. Based on this, if we were to normalize this wave function, we would say from -infinity to infinity, our wave function, the probability of our wave function of finding it somewhere, should be equal to 1. But if we divide this into intervals, we would have that from -infinity to a -2, we have psi of x, probability of that, squared dx, plus from -2 to 2, we have our psi of x, but it's equal to negative a in this range, that's squared dx, plus, and then from 2 to infinity, we have our psi of x, probability of density of that, integrated over that whole range. All this should add up to 1. But our wave function is 0 elsewhere. So these two terms are 0. And we are left with this middle term, which is going to be a squared x, evaluated from -2 to 2, and that should be equal to 1. So we have that a squared times 2 minus a -2 is equal to 1, or a squared equals 1/4. Hence, a is going to equal plus or minus 1/2. However, we can see from the graph that our function psi of x is less than 0 over this range. So we choose the negative portion of a. So a is going to be equal a -1/2. So that will be our answer. A is equal to a -1/2.